Good morning, ladies and gentlemen. Well, not good morning, but nice to see so many of you here. By the way, this is an introductory talk, so there are other different sessions out there. Some of you really know what I will be telling, so this is your last chance to go to Brandon or so. On the other hand, I will show you some live coding, and this is your chance to see me fail, but please don't throw eggs or anything at me. Yeah? Okay, so I'm Heiko Seeberger, and working for TypeSafe since 2 days. And it's a great pleasure to talk to you here. Okay, I want to talk to you about the ease of Scalaz. We all know that Scala is an object functional language, so why do we need another library? Why do we need Scalaz? What is Scalaz? Well, it's purely functional, so that's the difference to the Scala libraries. It offers a lot of cool things, data structures, and especially type classes that bring a whole machinery of nice features. It is a Google Code project, so it is an open source project, and actually the source code can be found on GitHub since, I don't know, 1 year or so. Who of you has already played with Scalaz? Oh my God, that's crazy. Okay, so maybe you can help me out if I get stuck. Sometimes we hear that Scalaz is too complicated. I think sometimes we also hear that Scala is too complicated. And well, that depends on your point of view. If you try to look into the implementation of Scalaz, then maybe it is complicated. Okay, maybe. But don't worry. Just use it. Using Scalaz can be really handy. And that's what I'm trying to show you today in the next 20 minutes. Okay, now, what's wrong with this code? This is not Scalaz yet. Tell me, please. Come on.
You're comparing option, equal for option and string.
Exactly. So, shit happens. That's an option. Yeah. That's not an option. And I have been working with Scala for some years now in real-world projects, and things like that happen all the time. We cannot blame Scala for that because this equals has to be the Java equals in the end. So what we would like to see here, or what we really would like to have here, is a type safe equals. And now I will show you how we can achieve that. Okay, let me switch to my nice Eclipse IDE. I have been an IntelliJ fanboy for 2 years, but since Scala 2.9, I switched to Eclipse and I really like it. So, yeah, really, I really like it. You come on, and that's the reason I wrote a plugin, an SPT Eclipse plugin. You can see it here. I start Eclipse. This is, of course, SPT, the one that Mark just published, the new one. And as you can see here, you've got an Eclipse command which will create you Eclipse project files. And you can also create subdirectories, skip root. So it's first version. I released just the first version of that thing, and together with this, you can really use Eclipse very, very nicely. Okay, type safe equals. We would like to have something like that. Okay, we need a different operator, of course, and in order to make that work, we need to import Scala. Well, let me show you a little completion. Oh. So, and now you see a compiler error, right? That's very helpful. Now we can see what we did wrong and try something like map here, get URLs. Is that correct? No, what's wrong? This is an option. Map. Compare it to.
You need to parenthesize up to the close friends.
No, I don't think so. Oh, really? What should I do? Ah. Use a dot after what? I'm sorry. So, look what I'm doing.
Don't you want to do getter out inside the map?
No, just maybe enclose the argument to the map function in friends and do a dot. It's
I think you have a non-white space character that looks like white space.
Uh-huh.
Illegal characters of that
Delete the
size.
space and type
Delete the
the
space
new.
and put it back, that's right. It wouldn't say illegal character if it was a normal error.
Woo! Thank you.
That's right, we just manipulate white space.
Who was that, Paul? No, thanks. Great.
We both knew.
Okay. So right now we have this great triple equals operator, and it is type safe, which is the name of this company. So I like it very much. I would like to show you how we can implement that on our own. It's not too complicated. What we need is a implicit conversion. We have to convert something to a type safe equals. This something is an A. Okay, and now we need a class A. Class equal. Of course, this has also to be parameterized, defining this nice little function. And now we can compare two things in a type-safe fashion. In order to make this compile, of course, we still have to import it. Right? Okay. Oops. Oh, this is not good for Eclipse. Here we go again. Okay, so this is basically what's implemented in Scalaz for operators like that. This is called type class design. Actually, it's not really. It's very common here. Okay, this was triple equals, the easy one, the really nice one. Who's using that already in projects? Oh, only 5, 6, 7? Okay, good. The next thing I would like to talk to you about is how we should handle with effects. What are effects? I'm not sure if I really use this term in its proper meaning, but anyway, if you look at that code, things can go wrong, like exceptions can be thrown if you use the wrong index, or if this thing cannot be converted to an int. Now, what can we do? We could use try-catch statements and stuff like that, but it would be much nicer to wrap it into something. I'm sure you all know option, or maybe also either. And Scalaz comes with a pimped either, which is called validation. Okay, I will go to the use case. Okay, so this is now the use case for the type safe equals. No, that's the use case for the effects. Let's return a different type here. Let's return the Scalaz validation. Like in either, it takes 2 type arguments. Let's use a string and an int. So the right one, the first one is for the exceptional case, and like with either, the right is for the correct result. Now we have to deal with the exceptions that can be thrown, and there's a nice little control abstraction in the Scala library. I didn't know that until some weeks ago. It is in Scala util control, and it's called exception. And there are some methods you can use to deal with exceptions and make options or eithers out of it. So I will use this catching method. And I want to catch, what can go wrong here? Index out of bounds exception. Index out of bounds exception, or class of number format exception, right? Okay. Now we can catch these and then create an either for a block of code. Oops. For this block of code. Now what we have to do is match on the result, and if it is a left with a index out of bounds exception, we can return an error message like this argument is not there. And we use the method fail to make a validation failure out of this string. This fail comes by implicit conversion. Each object is pimped if you import Scalaz into your scope. We also have to take care of this number format exception, of course. Then we can, this thing cannot be converted to an int. There's no int. Fails also. Okay, and then we have the right case with a number. We make a success out of it. Okay. So, very nice. We have now a method arg that returns a validation type. So we no longer have to deal with exceptions. Of course, the code doesn't compile here. What we could do now is that we do something like that in order to take care of what can happen, like if it is a tuple of success, I0, I1, and so on, then we do our calculation that we really want to do. And in any other case, we say that's a big failure, okay? But that's not where we really want to be. It's a nice first step, but it's not the end. So how can we process effects? We have now encapsulated those effects into this validation type, but handling all the different results is really clumsy. And as you can see here, it's only for 2 different effectful computations. If you imagine we had, I don't know, 4 or 5, then it's simply not doable. So this is where another very nice type class from Scalaz comes into play, enters the game, and This type class is called applicative functors. Maybe you have heard about it. In the end, it's not really necessary to know how they work. They offer, or the whole machinery from Scalaz offers cool operators you can use to make this dealing with the effects really easy. Let me show you. We have our arguments, and we combine them using an applicative builder operator, and then we call the function we want to call. In this case, let's just add those two. Et voila, that's it. Let's run it. Okay. Oh, I forgot to format. But as you can see here, we have two error messages which are concatenated together. Those are two strings, and the machinery here will accumulate all the errors, and as long as this thing here, the type parameter for the validation, is something that has an append method, there's a type for that, is called semigroup. All those error messages will be accumulated. In the case of strings, they will just be concatenated. So let's use something more meaningful, like a non-empty list of type string. And then, of course, we have to create non-empty lists from those error messages. And let me again fix that, what I forgot. Okay. If we run it now, you see that we get back a failure of a non-empty list with two error messages. If we run it again and apply only one argument instead of 0, we have only one error message, and of course now we get back a success. So this applicative functor thing is really very useful if you have to deal with a lot of these effectful arguments or effectful computations that return an option or an either or a validation. So Scalaz has a lot of type class instances, for example, option, either, validation, and some other classes from the standard libraries. So you can use it for almost any types you have to use. You could, of course, write your own type class implementation if you have a type which is not covered by Scalaz here. How much time do I still have? 10 minutes? Okay, then I would like to show you something, another very nice thing. Sometimes you get back not only a single effectful argument, but like many of them. Let's write another method. Call it args 1, 2. No, we have 1, 2 already. 2, 3. And that should return a sequence of arg. We call 2 here and arg 3. Okay. Now we cannot simply introduce it here, of course, because then many things go wrong. Of course, the type doesn't fit anymore. We don't have a validation here. We have a sequence here. And what should we add here? So what we really want to do is we want this sequence of validation to become a validation of sequence, right? And in order to do that, there's a very nice method called sequence in Scalaz, and you just have to apply some types to make it work. Let me call here A and B. It's not right, of course, but I will fix that later. Then we can do it like that and call sum here, and everything should work out well. Now it gets a little tricky. Which type parameters do we have to pass here? It's not possible in Scala to use higher kind of type constructors with several arguments and to fix all but one. And therefore, there's a neat little trick using type lambdas. We create a type here. And that's, of course, we want to take care of validations. Validation of non-empty lists of string. And the second thing is an int. No, that's fixed. So now we defined an anonymous type, and we gotta get this type out of that. Oops. Sorry, guys. As you can see, this is really tricky, and therefore I have my little cheat sheet.
Your underscore should be a B.
My underscore should be a B.
Yeah.
Ah, thank you. Yes, of course. Now, while this is not really nice to write down, if you once got your head around it, it doesn't take too long to get it right. Basically, what you define here is a type constructor for a validation where the first argument, the first type argument, is fixed to a non-empty list of string, and the second type argument is free. Okay, and using that, as you can see, the code compiles again. So we have a method here that returns a sequence of validations, and we just turn it around and make a validation of sequence out of it. Okay, now let me show you a real-world use case for that. As I mentioned earlier, I've got this project called SBT Clips, and I don't know if Mark showed these things to you, but the API of SBT returns a lot of options, and I have to deal with all those options. So if you look here, the project name, the Scala version, the base directory, the compile directories, the test directory, everything is an option, and I have to take care of that. I have to deal with it. So these values are effectful, right? And also here, test directories, compile directories are actually sequences of option. So if you look here, you see what I'm doing in SBT Eclipse. I take all those effects, some of them are already sequenced, and I call this save Eclipse file method on it. And then again, I pattern match on the result. Is it a success? Then I say, okay, successfully created an Eclipse project for you, or I have all the failures accumulated, and the user can see, okay, there was no base directory, or there was no this and that. So I'm really happy that I introduced this. Before I did it, I had a huge lot of if, else, and stuff like that, and try, catch. And it was simply too hard to understand that kind of code. While right now it's just from here to here, so I think it's pretty comprehensive. Okay, great. That was what I wanted to show to you, and we have got 2 more minutes for questions.
We have 5 minutes for questions.
Okay, then we have 7 minutes for questions.
Could you have avoided this last type you've introduced by making the type of the seed more explicit?
The question was if I could have avoided the anonymous type, the type lambda, if I...
If you would have made the type of args23 somehow more explicit?
No, unfortunately not. What really would be nice would be something like that, right? That would be nice, but that doesn't work. And this other thing, this type lambda, is just a trick to get that done. No more questions? Then thanks and have... Oh, sorry, there's one more question.
How does validation compare to box in the Lift API?
The question was, how does validation compare to box in the Lift API? Box has been very controversially discussed. Validation definitely is an applicative functor, and there's also a monad for it, but they are not compatible in the way they should be. But if you look at box, it is different. It is definitely not a monad in that sense, in the pure sense. But I think you're not really concerned about the type classes or the types, but more from the user point of view, right? So from using box, I have to say, because I had several Lift projects I was working on, boxes are really nice to work with.
Are your applicative functors covariant in their type, in their parameter type?
The question was whether applicative functors are...
Yours, the ones you have implemented in, the ones that are implemented in Scalaz, are they covariant in their parameter type?
The one that are implemented in Scalaz, if they are covariant in their parameter type. I've got no clue at all. I'm sorry. We could have a look at that later. I've got the source code on my machine. I don't know. Yeah, Jim.
Validations in 4 comprehensions, but under those circumstances you don't accumulate errors. Is that correct?
The question was whether validations used in 4 comprehensions don't collect the errors. And that's correct. And that's the reason why the monad type class has been removed from Scalaz and then introduced again, but it's not automatically imported with those imports here. You have to use a hidden import to really import it. If you want to aggregate or accumulate errors in a 4 comprehension or with flat map, then you have to use the either from the Scala library. What I don't think that's bad, because what you typically want to do with validations is just use them as an applicative functor to really run all those effectful computations. You really want to get all the errors, like, oh, you missed the first parameter and you missed the second parameter, and the third one could not be converted to a string. Like if you have a web form or something like that, you want to show the user everything he did wrong, right? So for this use case, you wouldn't want the accumulation to be stopped as soon as the first error occurs.
Yeah, at the moment I'm trying to study Scalaz, but the only effective way I found is by starting studying Haskell. And because I don't have a functional background. I was a Java programmer, and of course I miss all the theory of, let's say, applicative functors, stuff even crazier like arrow or stuff like that. So I'm trying to figure out from Haskell how this stuff works, and it's very, very interesting. But I wanted to know if, in your opinion, if there is let's say, a shorter way to do that, because it's a bit embarrassing, it's a bit awkward to learn it from Haskell and then it translate to Scalaz.
I'm sorry, but that was the way I had to go too. There are really good Haskell books out there and tutorials and examples, but nothing like that for Scalaz yet. I think Runar is just writing one, but I don't know when he wants to finish that. So right now, it's the only source.
I mean, how you are you doing the same? Are you starting from Haskell or
Reading Haskell books, or
Yeah, okay.
yeah, to get the whole concepts.
So I'm following the right path.
I think so.
Okay.
At least that's my experience. Thanks, guys.
Okay, that's good.